Hello and welcome to Empirical Methods. It is my great pleasure to welcome you here. I am of course biased, but I love this class and I love teaching it. It's my sort of pet class. I'm very happy to share this with you this semester. This is a somewhat unusual class in the computer science department. I try to find more instances of it elsewhere because I want to copy all the good ideas that other people have come up with. So I can share them with my students. I don't know of many courses like this that are offered in CS on research methods for our graduate students. There are some that I've been following. This one started with Jim Herbstleb and Marcelo Cataldo in our department a long time ago. They have all since moved away from this. I took it over at some point. The current version that you're taking is very different from the one that they were offering back in the day. I don't know if it's better or worse, it's just different. And there's a few similar courses offered elsewhere. There's one in particular that I'm a huge fan of. If you haven't seen this, I highly recommend you take a look. There's these folks at University of Washington that wrote a really good book called, I think, Calling Bullshit, and are offering a class with the same name. And this is really, really fun class. I think it's very popular. It's undergraduate level over there, very popular. I share much of their philosophy for, calling bullshit in research claims that you find in our research papers. So hopefully this is kind of what you'll be getting by the end of this class if you stick with it here. I want to tell you a bit about the topic today and hopefully hear a bit about your backgrounds and interests and what you're hoping to get out of this. And I'll tell you a bit about kind of how the class is organized and what you can expect throughout the semester. So that's roughly the plan. Feel free to interrupt me for anything. This is a friendly, environment. So I'm happy to have conversations with you about anything. Okay, so I think, let's see, who here is sort of CS? Okay, most of you. Who is not? What else? S3D, yes. Which program? Right. So that I would count that under CS.
The CMU program with Portugal.
Oh, welcome. Nice to meet you. Yes, there's a number of you. So yeah, very good. Thank you. Thank you for coming. What else did I hear? Was there more? I know most of you. Did we meet before?
Yes, yeah.
You are Rob.
Yes.
Oh, welcome. Thank you very much for being here. Yeah, I appreciate it. Yes, so you are sort of a seasoned senior researcher. So there's probably more that you can teach us than the other way around. But thank you for coming to this class. And we have anything else? Okay, so I think many of you will relate to this. So imagine some hypothetical research programs that you might recognize yourselves in. Maybe you are sort of the scientist types. You like to study problems to understand them better. Maybe you like to study practitioners and whatnot. For example, you might be studying people in your area, in your field, and understand how they work and what challenges they have and so on. So that's sort of a very common type of research that lots of people do sometimes. Maybe you're a little farther ahead in this process. You've already done some of this work or other people have done this work for you. And you are well aware of some existing challenges, so you're working on building some technical solutions for those, or to inform the design of these, or even build them yourselves, whatever it may be. That's another example. Maybe you've already built something. You have an amazing new tool or technique or algorithm or model or coding agent or what have you. You've built something amazing. It's the next best thing since mayonnaise. And your advisor is asking you to design a good evaluation for it so that you can convince the reviewers for your paper to accept it and whatnot at your top conference or something like this. So anybody recognize themselves in any of these? See a bunch of nodding. People are melting away from the heat. I've called somebody. They're hopefully going to come and fix the heat. So bear with me. Okay, so whatever these plans may be, you will probably want to do a number of things as part of this. You might ask yourselves what data might you need to collect and how to get it, where to collect it from, what will you do with this data once you have it, how might you analyze it in such a way that it will help support the claims you're looking to make about your contribution in your respective papers. What kinds of evidence might you need to collect to demonstrate that some particular approach is better than another, and so on and so forth. What is enough evidence to convince yourselves and your advisor and your reviewers of your papers that the work you've done is sound and worth publishing? So, no matter the reasons for doing a study, you will probably ask yourselves this big question: how do you validate the claims you're hoping to make in those papers? Sidebar here. Probably the number one reason why research papers get rejected when you submit them for peer review for publication is not that the work was bad or the tool didn't work or whatever else, but it is that you're claiming something that you're not offering enough evidence for. Okay, so it's not that your tool isn't working well enough. It's rather, more often, that you're claiming that your tool is doing more or working better than it does. And reviewers get really mad when you, these good reviewers get really mad when you make claims that you do not sufficiently support with the appropriate empirical evidence. So just as an aside. Okay, so this course basically can be boiled down to this one sentence, which is, it depends, right? So if you're asking, how do you validate your claims? It depends. It depends on lots of things. We're going to learn this semester, a number of these things that it depends on and how to reason about this. So, this is where empirical methods come in. Another aside, I was reading a paper yesterday, and think a better term to describe what we're doing in this class would be empirical strategies, research strategies, rather than research methods. I think sometimes people very narrowly refer to methods as purely data collection methods. And we are doing much more than just data collection. We're thinking, A, we're thinking about analysis a lot of the data you're collecting, and B, we're thinking much more broadly about how to design research studies and piece together components as part of this research study, which goes much beyond just data collection itself. So I think technically research strategies would be a better term, but I think research methods is more commonly used, so I'll stick to that. Just be aware that you might encounter this as strategies as well. So there's lots of these. They are used in many forms and in many phases of research. They're used to understand a problem or current practice. They're used to help design a solution or demonstrate its utility and so forth. And all of these different methods have their own standards of rigor and techniques for applying them soundly. So we will be learning about this. Bad news is that there's no silver bullet. There's no single best method that you can always use to do everything you need to do to support all the claims you need to support. It all really depends on what the claims are and so much more. So we will learn a lot about how these different things are limited and how to deal with their inherent limitations. But the good news is that when applied correctly, these things can be extremely useful. And in fact, so none of this is sort of fundamentally a software engineering or a computer science problem. This applies to research in virtually all domains of science in much the same ways. So in that sense, this is a very generic science class. Okay, so selection of methods depends on a number of things. Here are just some examples of the things it depends on. Your philosophical worldview about what constitutes a scientific truth is one thing. So we're going to talk a minute about this, just to I'm curious to see where you all are coming from. The nature of your contribution, the specific research questions, how much is known about a particular problem, the one you're working on at the time, and lots of others. Okay, so here's one way to think about research approaches, strategies, methods. You can imagine that research exists along multiple continua spectra. Two examples. One is this dimension going from inductive to deductive. Have you heard these terms before? Inductive and deductive? What comes to mind? Proofs? Yeah, it's good.
Bottom up versus top down.
Yes, yep, that sounds right too. Okay,
Specific.
say again.
General to specific.
Yeah, yes, also, yeah, very good, thank you. Another dimension you could sort of think about research methods or strategies along is qualitative on one end and quantitative on the other. So this is maybe something you're more familiar with. You've seen and heard this before. So let's talk a bit about these worldviews. It's basically two, I think, common worldviews when it comes to doing science anywhere, including in our field. The one that you're maybe most familiar with is the so-called objectivist or deductive approach to research. And you're probably most familiar with this from, I don't know, early school, because this is often what's referred to as the scientific method. So, you've probably heard about the scientific method when you were, young in school or something, I would think at some point. So, the people who, I don't know, are excited about the philosophy of science, think about this. And there's some fundamental assumptions that underlie this worldview. One is that there is some external objective reality out there. There's some real world that's objective and it exists independently of the researchers. And the more we can collect objects and evidence and measurements and whatever else from this or about this external world, the better we can understand it. So think Newton and gravity and so forth. That's sort of the vibe here. Okay? That makes sense. So how do we build knowledge when we do this? By developing increasingly refined understandings of the causal inner workings of the world and the mechanisms behind the phenomena we're observing. We're dropping apples because we're really trying to develop this understanding of the causal mechanisms behind, gravity, for example. So, Sham mentioned this earlier. You can see how this is top-down or reductionist in nature, because you usually start from some general abstraction, some theory, some conceptualization, and you go down from there to observations and measurements in a particular context. Okay. So research questions here are often testing some cause and effect relationship that underpins a particular phenomenon. So that's sort of a common approach here. So you often start with some higher level theory or concept or whatever, and you derive particular hypotheses about that phenomenon that apply to a certain context. And then you collect data and you try to test your hypothesis. And the findings from that test may either support or falsify or help refine or whatever, your hypothesis and therefore your theory that you started with. And you make revisions to that and you keep doing this over and over again until you're satisfied that you have yet to falsify your current theory. Right, so people commonly do experiments for this. So that's one common worldview. You will see this a lot. You will have seen this historically over centuries in the physical sciences and whatnot. Another popular one that you will also see a lot is the subjectivist or inductive approach to research. So this is quite different from the previous one. Here, there is no objective external reality out there that we get to observe. Reality is a social construct. Okay, so the reality of some group of people could be very different from the reality of a different group of people. It's a social construct. It's not this objective thing that so exists independently of the observers. Okay. So it exists because people, share interpretations and understandings of this reality that's out there. I don't know. Think of, I don't know, political leanings or some such thing, for example. So, how do you then, as a researcher, try to make sense of this reality? It's not this, objective thing that you can just put your finger to very easily-ish. You have to do this. You make sense of this reality through the lens of the people that experience it. Okay, so you explore the meanings constructed by these people that experience that reality. And you try to understand their meaning of it, right? Because there is no, objective meaning of it that you can sort of understand independently. Okay, does this make any sense? So, right, so this is constructivist, meaning you're constructing it bottom up. And you usually start in the opposite direction. You usually start from some specific data, and you go from there to a more general abstraction or concept or conceptualization or theory. These are all words we'll be using. And it's important to remember that knowledge is subjective, right? So it all depends on the perspective and the lens you are taking. So how do you go about doing science in this, worldview? You try to collect data from a multitude of perspectives, and this is usually a good idea because it gives you a richer, more nuanced understanding of the phenomenon you're studying, and exposes you to more of these meanings that people construct about it, and you this way get to have a broader understanding of the phenomenon itself. So, research questions in this, common research questions in this worldview have to do with exploring phenomena to increase our understanding of them. So, typical approach, you have some particular thing you care about, a phenomenon or a new thing or something. You collect data about it, and you look for patterns and sort of construct this understanding from the bottom up. You try to abstract away from the things you're observing empirically in a bottom-up fashion. So you see people that ascribe to this, they often use data collection methods like interviews and focus groups and observations of practitioners and whatnot, because this sort of gives them a way to explore this reality through the lens of these people that experience it. So these are the two, I think, most common types of beliefs that are held by researchers across all domains of science. People refer to these as philosophical worldviews, and you could sort of see how, based on these worldviews, you could have a preference for different research strategies or research methods and so forth, different questions you might be going after. So often the goal with the objectivist approach is to verify or falsify some theory. Often the goal with the subjectivist inductive approach is to create some theory. Okay, so bottom up versus top down. So these are two very common ones. There are, in fact, a couple more that you'll also probably encounter to some extent. The pragmatist is what I think I'm most aligned with myself. I'm curious to hear where you lie on this spectrum. So, pragmatist in this sense is somebody who cares more about the problem than about the method or the so what constitutes truth in that sense. And a pragmatist would choose whatever method is available and is useful to further their understanding or solution of a problem, rather than philosophically sticking to one or the other. So I think I'm most like this. You will also, I think, often find advocates minded researchers. Critical theorist is another term for this. For example, in human-computer interaction, there's a lot of this in, I don't know, all of the ethics around AI and so forth. There's a lot of this and other areas of computer science. So here people think of research as a political act. You're only doing research and building knowledge in service of some of your peers. You're sort of usually pursuing some deeper underlying social cause, and that's really what's driving your research, and you're ultimately looking to make some change in society directly as a result of this research you're doing. So not knowledge for the sake of knowledge, but it's knowledge for the sake of enacting change in the society around you. So this is also, I think, very common in parts of CS. So you'll see this quite frequently. I'm curious where people are here. If you were forced to pick, the one that most closely resonates with you. There's no right or wrong here, by the way. This is just sort of beliefs. So I'm curious. Yeah, I'm curious where people are. Let's do a quick poll. Anybody here a positivist? Okay, a few. Any constructivists? Okay, also a few. Any pragmatists? Maybe the most so far. Any advocates? Okay, did you vote twice? Yeah, so that makes sense. You can see how all of these are common, even among this relatively small room, and certainly across a broad and rich field of research like ours, you will find examples of all of these. Yep.
I don't think these are exclusive, right?
No, not exclusive. I think you could often be anywhere on the spectrum.
The bottom two seem more like approaches, and the above two seem more like methods. I don't know.
It's more about what do you consider knowledge? What counts as knowledge, and how is it constructed, is how I think of it. So here knowledge is only exists in service of society. Here knowledge is anything as long as it's in service of some problem or tries to solve some problem. The top two ones, maybe you're sort of more kind of fundamentally inclined to accept something that's truth more than others, that sort of thing. There is no value judgment here. All of these are perfectly valid worldviews for doing research. I'm only mentioning this because they tend to influence the kinds of research that people do, the choice of questions and problems they take on, and B, how they approach them. So it's useful to be aware of these because the nature of the contribution you might be making in a research paper might also differ, depending on kind of where you're coming from.
It's
the construction of these categories from a constructivist, generated or quickly these tested.
How did they come up with these labels, you mean? I don't know the history of the philosophy of science here. There's good sources on this. I can point you to some. But yeah, I don't know enough about the philosophy of science myself to really tell you about the history of it. Does anybody know? Yeah, sorry. No, I don't have more on this now. Lots of good readings on this, though. You'll find a lot about this. Yeah. At the end of my deck. Oh, by the way, speaking of, I guess I'll get to this later. There's a website for the class where all of these slide decks are public. I will also usually post all of the recordings of these lectures as well. So I try to share all of these materials. And you can also find all of the materials and recordings from previous instances of this class. I'll tell you more about this a bit later. Yeah, please.
where we can find these entries, because I don't really see slides on people.
I don't know that I've posted today's deck yet. So because I had a meeting that I was late from, and I didn't get a chance to post anything before class. I would usually try to post everything before class, but today I did not get a chance. So if you'll bear with me, I will do it after class as soon as possible. You will find a very similar deck to the one I have today in the previous instance of the class from spring 2024. If you need to do that now, let me. Okay, so right. So this is sort of one way to think about methods. Another way to think about methods is along this qualitative to quantitative dimension. So usually a good heuristic here is to ask yourselves, how much do you know about the particular thing you're studying? How much knowledge is there about this particular phenomenon already? The less we know about something, it's more likely that qualitative research methods would be more useful. They would sort of help you better understand the problem you're interested in. The more you know about something, the more you can, in addition, also begin to, test and measure and whatever, so specific hypotheses about the phenomenon you're interested in. So there you can begin to use, quantitative methods much more effectively, design experiments and so forth. Right. So, but this is a function of kind of how much prior knowledge there is about a particular phenomenon. So qualitative methods are useful in sort of early little knowledge areas because they can help you paint this very rich picture of whatever it is you're trying to study. But they're not very precise, right? Again, like reality is a social construct, so you're sort of dependent on this, the subjective interpretation of the world. Not a lot of precision there. Hard to count things or measure or argue, which is better and so forth, which is more efficient, etc. Quantitative methods can be very precise. You can very precisely estimate things, you can measure things, you can run statistics on top of this to make claims about distributions, etc. You can make causal claims if you have designed a good experiment or have a good causal inference strategy, etc. You can be very precise, but you usually cannot paint a very rich picture of what it is you're studying. Usually, the more you increase precision, the more you lose richness because you sort of narrow down more and more what it is you're studying necessarily, right? In order to measure things and so forth, to be very precise, you sort of have to narrow down something, your object of study a lot. So you lose this richness that you get with these subjective but much richer methods. So we talked about this, right? So often what you will see as part of a research program, not a paper, but a research program, meaning, for example, your PhD, right? So a series of studies, or for example, your faculty advisors, career or something like this. So your career, what you will often see is a progression from the more subjective, qualitative methods to better understand some problem, to more precise quantitative methods to test hypotheses and make claims and so forth. And you might see this in sequence. That's often a common progression. It doesn't have to be. You might see them in parallel sometimes. We're going to talk a lot more about mixed methods strategies throughout the semester and kind of what different mixed methods designs can allow you to do and what their strengths are. You might also see the sequence repeating itself a lot. So, you've maybe you've walked through the steps, you've understood some problem that practitioners are facing, you've designed a solution for it, you've evaluated it empirically and deployed it and whatnot, and then you move on to the next problem after that, and you start over by, understanding it better and then building a solution for it and so forth. So you might see yourself repeating these cycles. Okay, so then here are some more concrete examples of strategies or methods that you might see being used along this spectrum. So we're still going from more qualitative on the left-hand side to more precise quantitative on the right-hand side, richer on the left, more precise on the right. So ethnographies, have you seen these being used at all? Anybody here familiar with ethnographies as a research strategy, research method? Very interesting. So this is sort of a very technical audience in the room right now. So ethnographies are not as common in computer science or software engineering research. You will see them in all fields of science. So here is an example. This is a study of health professionals and surgical teams. I've highlighted some interesting bits from the abstract of this paper. Talks about what the study does. Professionals, highly interdependent, work under time pressure. It is of particular importance that teamwork is well functioning in order to achieve high quality treatment and patient safety. Although extensive research has been carried out regarding relational coordination, no study has explored how relational coordination works at the micro level. The purpose of the study is to explore communication, et cetera, et cetera. Ethnography conducted involving participant observations, 39 surgical teams, plus semi-structured interviews during a 10-month period. In 2014, 2 orthopedic operating units in a university hospital in Denmark. So the researchers shadowed these practitioners over 10 months in the hospital. Okay. Observing and recording and whatever, everything they're doing. Right, they were part of these teams and conversations and whatever else. They were observing all of these interactions and collaboration and et cetera, teamwork. They were doing all of this in person, on site, in the environment that these practitioners were working in. Right, the researchers went into the wild and acted as ethnographers. Right, they studied just like you might, I don't know, in the old days. Go study some, I don't know, tribe in the Amazon or whatever, right? Some such thing. You go and become one of them for a period of time, study everything they're doing and observe and try to make sense of this. And in the end, they also follow this up with a series of interviews to learn more, elicit more information from the people they were studying. So you see a combination of research methods here, but the driving one, the dominant one, is this ethnography, right? Researchers becoming ethnographers. This is, by the way, not a atypical thing. I mean, it's rare, but it's not impossible. You will often see, you'll sometimes see this in software engineering and computer science research. This is a famous paper, software engineering paper or programming languages paper, of an ethnography of programmers to study their copy pasting behavior.
I mean, all qualitative studies are ethnographic studies, right? No.
Not necessarily. An ethnography requires direct observation by the researchers of the practitioners, doing whatever it is that you're studying. In my experience, most qualitative research that you will see in computer science and software engineering is either using data collected via interviews or from surveys sometimes. I think interviews is most common. So in an interview, you don't usually observe people in the wild, doing the thing you're studying over long periods of time, potentially, right? You're sort of asking about their experience with what it is you're studying, but you're not observing it directly, usually.
Would log traces of somebody's work count as ethnography?
No, a log is some, archival analysis You don't observe them doing the thing. You're studying some artifact that they left behind. So I would say no, not in that sense. You would, an ethnography is, you become one of them. You eat and sleep, in the same tent or whatever, and you observe them doing whatever it is they're doing. So, you can, I guess, see from this how something like this could give you extremely rich insights about the phenomenon you're studying. Right? There's no better way to like understand how something is happening than to be part of it yourselves, right? For potentially over long periods of time. So this is probably the richest understanding of any phenomenon you could possibly get as a researcher. But right, we talked about this. Yeah, but at the same time, it comes with some limitations and some risks. One, it's super effort intensive, so it's probably not surprising that you here were not familiar with this method because it's not that often that it's applied because it's so effort intensive. Imagine you're studying, I don't know, software engineers or whatever. You have to spend a year with them at whatever company they're working at, or some such thing, just to observe them before you can collect some data, and then you come back and start analyzing what it is you've observed, right? So very rarely do people have the ability, researchers have the ability to do something like this, very effort intensive. It's also, you may get trapped by the participants' perceptions. There are some famous stories of this back in the day when researchers would end up fabricating narratives that had nothing to do with reality and so forth. It's also
So I had a question. What do you mean precise here? Is it like how narrow we can go? Like, are we trying to say that it is broad, or like what is it precision in the qualitative results or like quantitative results?
Oh, so precision in precision in a in, claim sense, or
For the knowledge that we are getting out of this kind of research.
so you're getting a very rich picture. You can sort of understand many different aspects of the phenomenon you're studying. You're getting a very rich experience. You get to you live it yourself, perhaps, and so on, experience it firsthand. It's not very precise in the sense that you can make, quantitative, falsifiable causal claims. You cannot make predictions really in that sense. It's all very, subjective. It's based on your lived experience and interpretation, of what it is that you're studying. It's usually small scale. There's only so many of these you could do. So you have in that sense, limited, very rich, but very narrow, right? Limited understanding of what you're studying because you've only observed it in maybe this one context, even though very richly, right? So you cannot sort of more generally make the strong causal claims and predictions about the phenomenon. You could try to make some, in that particular context, right? But not.
Yeah, I was trying to understand that why do we not the term narrow? Again, not about terms itself, but is it something more than which is not narrow? It's covering a broad area, or it is more exploratory in nature?
When I use precise here, I'm thinking more, numbers and measures and sort of falsifiable claims in that sense. Testable hypotheses, falsifiable hypotheses. So that's sort of, I guess, what I mean by this. That makes sense?
I mean, these are still falsifiable claims, right? People can do another study on a similar group and falsify or approve your.
Of course, no, I'm referring specifically to what, you as the researcher can and cannot claim yourself based on this particular study, not what's possible afterwards as follow-up by you or others. Right? But just, given this, data or context or study design, what is it that you can and cannot claim soundly?
So you simply cannot make falsified.
You can make you can draw hypotheses or theorize or whatever, but you cannot test them and falsify them yourself usually.
Makes
Right? You can, yes, you can hypothesize, not test. Yeah, please.
Are there temporal bounds on these other ethnography studies? So a 1 hour interview is fairly too small to be an ethnography.
Yeah.
10 months is an awful lot.
Yeah.
Where does it stop being one or the other? So if you have a 2-day site visit where you can see people working, but you don't live with them.
Yes. Yeah,
So is that?
excellent question. I genuinely don't know. So question is essentially, how little a time do you have to spend observing your subjects to be able to claim that you've done an ethnography? I do not know the answer to this. Let me try to think about this more and maybe get back to you next time. I don't think I've seen it used in research papers, referred to as an ethnography if it was as short term as you're describing, a couple of days.
Mhm.
But I don't know if that's technically illegal or not.
Curious question.
Yeah, I agree with the question. I just don't know. All right, excellent. Here's another example of a very influential paper. Maybe you have seen this already. Here, I've highlighted an excerpt here. Social applications on the web let users track and follow the activities of a large number of others, regardless of location or affiliation. There's a potential for this transparency to radically improve collaboration, et cetera, based on a series of in-depth interviews with users of the GitHub platform. We examine the value of transparency for large-scale distributed collaborations, blah, blah, blah. So, historical context, this paper, CSCW 2012, very highly influential paper that studied how people use the GitHub platform, which we all take for granted these days. So at the time, very little was known about the GitHub platform itself, how, if at all, it's different from other ways in which people were collaborating online to build open source software. And more importantly, why it seemed to be so popular. GitHub started in 2008. By 2012, it was on this sort of exponential growth pattern. And it was around that time that the world at large started to notice this GitHub phenomenon. It was changing the practice of software engineering. So the research team here, actually some colleagues here at CMU, they were intrigued by this new phenomenon. They were seeing this thing that they did not understand and seemed to not make sense. I think they refer to it sometimes as social media for programmers or something like this, because they didn't know what it was and why it was so popular. So what do you do when you have some new thing, right? That is in this case growing in popularity and whatnot. There's a new phenomenon. What do you do before you know what the problems with it are? You try to make some sense of it, right? And no better way, or short of an ethnography, no better way to make sense of it than to talk to a bunch of people, right, that are on that platform, that are using it, to understand what it is through their lens. So, see this socially constructed reality here, right? That the researchers are trying to reconstruct through the lens of the users of the platform, right? So they ran a bunch of interviews and tried to make sense of what people told them, about what the platform was about how they were using it, about what was special about it, and so forth. So point is, something like interviews as a data collection method, followed by some qualitative analysis of this data you're collecting from the interviews, super good way to make sense of a new thing, whatever the thing may be. Okay? It's very hard to look at something new at the time as it's happening and go say, oh, let me measure this and design an experiment and test this specific hypothesis about this or that. Very hard to do that, because you don't even understand what the thing is. Right? You don't even understand the problem well enough. Right? It becomes easier to do that as you understand the problem better. But this kind of qualitative research is really useful to make sense of what the problem is before you think about building solutions for it. So like, number one pattern, I don't know, that especially junior researchers or trap that junior researchers fall into is they jump to building a solution for something before they understand why they're doing that, what the problem really is, and in what ways their solution is needed, etc. So very good idea to make some sense of the problem before you start building solutions for it. Just as an aside, I thought they were coming to fix our temperature. They did not, but also it feels less warm.
Yeah.
Is it still aired out, the thing? Huh. So much for customer service. I think I want to talk to the manager. Okay. So, interviews, some form of structured interaction. Usually there's, I think the most commonly you'll see something like a semi-structured interview being used. That means you have an interview script with a set of prompts, questions for your participants. You don't go through it in a linear fashion like you would fill out a questionnaire. So in that sense, it's only semi-structured, right? It gives you a set of things, topics you want to talk about, but you don't have to talk about them in the order they are, mentioned on your script. And you have to give yourself the flexibility to follow up and go in whatever directions emerge as interesting as part of these conversations. So actually, it takes a lot of skill to be a good interviewer. And a lot of practice, and I don't think I am one, but some people are very good at this, and I found this to be very hard actually. Being a skilled interviewer to know when to go off script and pursue something that is emerging as interesting, and when to stick to your script, and also like how to get back on script, when people start rambling as part of your interview. So, interviews can answer questions about perceptions and opinions and so on. They can help you understand how something is done, or exceptions to something or problems people are having. And we'll learn more throughout the semester about how to do this rigorously. I guess one fundamental limitation, right? All of the information that you are gathering through interviews is necessarily filtered through the lens of your interviewee. Bless you. Right? So you don't get to observe something firsthand yourselves, right? You get to hear how your interviewees have experienced whatever it is you're studying. So you can, easily imagine, I think, how lots of biases can creep into this process, right? In a way that, makes it very hard for you to extract useful information from your interview participants. A couple of examples. Good luck asking people to recollect things that have happened in the past. I can hardly remember what I ate yesterday, let alone, how I felt or what I did, who knows when in some particular context. So that's very hard to get anything out of that. Or, good luck getting people to disclose to you, a stranger, sensitive things that may, place them in a negative light or are socially undesirable or whatever else. And lots of others. We will talk a lot more about this later. So it's really not at all easy to do this well. Okay, here's a different method exemplified here. We use difference in differences, a causal identification strategy commonly used in the social sciences to control for unobserved confounding factors and estimate the causal effect of working from home. This is a study done at Microsoft during COVID when people were asked to go home and work from home. Okay? Our analysis relies on measuring the difference in changes between those who worked from home prior to COVID-19 and those who did not. Okay. So the key idea here is that the researchers are trying to make causal claims about the impact of working from home on productivity of, I think, Microsoft employees. Is that right? Yeah, Microsoft. Okay. So they could not run a randomized control trial like people would do, in the medical field, right? You don't randomly assign some employees to working from home and others to staying in the office, right? I mean, you could in theory, but not in this case, right? Everybody was mandated, right, to work from home. You don't have the luxury of conducting a true experiment. So the question becomes, can you use observational data to still make, as close to possible, as close to causal as possible claims about the impact of this intervention, which is having people work from home, right? How do you do that? And we'll learn a lot about different causal inference techniques that you can use on observational data to try to make pretty strong claims about the thing you're studying, but without actually running a true experiment, which of course is a good idea if you can afford one, if it's practical and so on, economical to do so, but it's often not. It's often not possible at all. In this case, it was not physically possible to do so. This here, when you're sort of using causal inference or statistics, causal inference techniques on observational data, this is often referred to as a quasi-experiment. You'll also hear the term natural experiment sometimes. In this case, natural experiment would be appropriate because the pandemic was a naturally occurring phenomenon, depending on which conspiracy theory you believe, naturally occurring phenomenon, that just happened in nature. So you have this opportunity to observe its effects and measure those. So this, it's not very rich. You don't get to, understand all of the aspects of, for example, the Microsoft employees' lives and the ways in which the pandemic affected their lives and all of that, right? It's not that kind of richness at all, but it's very precise. You can, very precisely quantify how many more hours they worked per day, or how many more, whatever it is, if it's software engineers, how many more lines of code or fewer they authored, etc. Right? You can very precisely measure and quantify certain things very narrowly at the same time, right? You don't get to observe and measure most probably of the things that are relevant to these people's lives, how their situations at home impacted their productivity, etc. You don't get to observe and measure those, but you get to be very precise about the things you can observe and measure. Okay, yeah, so we talked about this. Yeah, we'll talk more about this later. Right. Here is another one still. 112 papers were randomized to be tweeted about or not. So this is a study on the impact of social media mentions, in this case, Twitter. This was in the old days before Elon destroyed Twitter. The impact of tweeting about research papers on the citations to these research papers. Okay? And the researchers here had the luxury of conducting a randomized experiment. Like they randomly assigned papers to either a treatment group where they get tweeted about or a control group where they do not. So because of this magic of randomization, you can expect that the two groups of papers are largely indistinguishable, largely comparable, right? So then, later on, 1 year follow-up demonstrates that tweeting results in significantly more article citations over time, blah, blah, blah. So a year later, you look at the number of citations to these two groups of papers, you compare those distributions, and you see whether or not the ones that were treated, meaning were tweeted about, became more popular. Right? But this allows you to make a pretty strong, more or less causal claim, right, about the impact of these tweets on the papers that were tweeted about, because you could, reasonably expect that otherwise the two groups were comparable because they were randomly assigned to the treatment in the first place. Okay? And so, of course, over a 1 year period, there's lots that can happen here. So we could talk about some of the limitations. But fundamentally, right, this is a really good idea. To the extent that you can run a randomized controlled trial like this. This is the gold standard for science in all fields of science, medicine being maybe the most famous. Right? All medical treatments, drugs, etc., to this day are evaluated in a similar fashion, randomized controlled trials. Right? You see whether the people who received the drug or the vaccine or what have you got better at a higher rate than the ones that did not. Gold standard for science. So great idea to do this also in computer science or software engineering whenever we can, but often we cannot. So we have to live with weaker methods. That's just the reality of the work we do. Okay, so you can see how on this scale, maybe experiments give you the highest level of precision here. Like you can make very precise causal claims about the impact of a particular treatment. We'll talk more about limitations and so forth. Okay, so bottom line, all of these methods have strengths and they have limitations. We will learn strategies to try to overcome their limitations and research designs that help us combine their strengths. We will do so through lectures that are here twice a week. We meet Tuesdays and Thursdays in this room at this time. I'm the instructor. I'm Bogdan Vasilescu. I do research in software engineering. I'm an S3D. I have taught this class a number of times before. My research these days is on the impact of AI on software engineering. Historically, it's been on open source software development. Happy to talk to you more about all of that. We have a wonderful TA this semester. Claudia is going to be our TA. She's not here right now, but she will help with a lot of logistics and homework and whatnot. So many of you know her already, I'm sure. I will be using Slack a lot for communication. I will create a channel for the class and add you all to it. This is probably the easiest and fastest way to ping me about things. It's also my probably easiest and preferred way of making announcements. Like, I don't know, if I'm stuck in traffic or whatever, running late for class or whatever else, it's the easiest and quickest way for me to announce that. So I'll be using that. We can also have, conversations about topics there. We'll have a Canvas site where we can have you submit solutions to homework assignments. It makes it easier for us to collect and grade those. Otherwise, you can always reach out via email. I'm happy to, I don't have a set office hour, but I'm happy to talk to anybody at any length about any topic. So just please feel free to reach out whenever you need to talk about anything. Most of the materials will be posted on this website. If you go there, you will also find all of the materials and recordings from previous instances of the class. The latest one was in spring of 2024. That's exactly 2 years ago. The class this semester will be very similar to spring 2024, except for a number of improvements that I'll be making along the way based on A, what I've learned from offering it last time, and B, what has changed in the world as we know it. All of this stuff with AI and whatnot that was not as advanced 2 years ago. So we'll be adapting to that as well. Okay. There we'll have roughly 3 types of meetings of classes. Sometimes it will be heavy on me lecturing on a particular topic. Sometimes it will be entirely hands-on. So last time we did this 2 years ago, we had a lot of meetings where we spent the entire class coding, in that case in R Studio, doing data analysis and things like that. I'll ask you to bring a device, and we will be, working on something in class together, hands-on. And that has been a lot of fun in the past, and I expect that will also be, fun to do again. So I would like to do that again. That's the second type of class we will be having. The third is presentations that you give. We have a reading list. These are papers that we've sort of curated over the years, and new ones will be added, I'm sure, this time around that I didn't know about before. Papers that exemplify, usually in a good way, the different methods we are learning about. So maybe I give a lecture about a particular research method, and then we read a couple, 2, 3 papers on various topics that use and apply that particular method. So you can see exactly how people do this, in top tier research, and get a much better sense of kind of how to practically apply these things that we're learning about. So I will ask all of you to sign up to present these papers. They're usually about 10, 15 minutes or so. You present kind of what you give a summary of the paper usually, and then discuss some of the strengths and limitations of the particular method we're focusing on, for that particular paper. And we will have a number of these. I expect at least 1, maybe 2 per person by the end of the semester. So you can volunteer and sign up for these. I'll share the link where you can just sign up. Everybody will do at least 1. Some of you may do 2. I don't know if we'll have everybody do 2 or not, depending on how many slots we have. We'll see. But you will read the paper carefully and prepare a short presentation about it and give that in class live to the rest of us, and then we'll have a discussion about the paper. So that's kind of the third type of meeting we'll be having. This is a PhD level class, so I expect that most of the work will happen outside of this class on your own. I share pointers to readings. I also share, we have a Drive folder with all of the curated PDFs with the different readings, chapters from textbooks, whatever else that I've put together over the years. You will have access to all of this. I will never in class be able to fully cover all of the details of any of these topics, like anywhere. So I really do encourage you to do a lot of this reading on your own. The books and whatnot, reading materials I share will usually have a better presentation that I'm able to give myself. Okay. So the main deliverable is a mixed methods research project that uses empirical components that we will have discussed in class. I expect two things here. One is about a month in, you will give a short, maybe 5 minutes, prepare a short 5-minute kickoff presentation where you outline the topic of your research project and a plan for how you might tackle that. So this is usually very brief. It outlines the question or questions, maybe some of the like why this is worth answering, kind of what's the state of knowledge, what's the state of the literature on that particular topic, some motivation for your question, and then a brief plan for what methods you'll be using, what data you'll be collecting, how do you expect you will get it, etc. What will you do with it? So just think project proposal style, kind of early. You've decided on a topic. Things can still change, of course, but you have an idea. It's concrete. You have a plan for how you might go about getting data. At the end of the semester, I expect roughly the research paper equivalent of that. So I expect you to will have done close to all of the work on this project and written it up in a similar way as you would write for a research paper that you submit for publication. It doesn't have to be submittable for publication by the end of the semester. The timing is very short, but I expect you will be close to that. I expect that you will have, for example, if it's a mixed methods study, I expect that you will have made substantial progress on at least one of the components, maybe finalize that, and have written this up, have some literature review written up, a description of the methods, description of the results, etc. So this has to be high quality, technical report, close to submittable, if you will. The saving grace here is that I hope that all of you are already actively doing research for your day jobs and will be using a project that you're actually already, if not, or planning to actually work on. So I'm of course happy to have you work on random projects. I'm even happy to give you projects. I have lots of ideas for studies that could be interesting if you don't have your own ideas. But this class is most enjoyable and most effective if you do your own research as part of it. I would like to help you improve how you do the work that you're doing anyway already, to the extent that I can, with this class. And otherwise, I would like that you are not distracted from your main mission, which is to do your research. Most of you are PhD students, to do the research that you're doing anyway. So again, this class is best experienced if you choose to double count for the class a project that you're doing anyway. In the past, I have observed that if you're doing for the class a project that you actually care about, and even better, one that you're actually working on anyway, you do a much better job at whatever it is you're doing than if you just do a random homework-like project that you only use for the class and nothing else. So, I mean, that's fine. You could do that, but I hope you do not. I would encourage you to use whatever it is you're interested in working on anyway, if not working on already. The only catch is you can't just submit something you've done already. It has to be work that is ongoing or work that you're starting, not just something that you've done already and you send me the paper you've already published or submitted for publication somewhere else already by now, right? So it's fine if you're working on it throughout the semester, but not something that you will have done and completed already. It has to be work that's new, because I want to have a chance to influence the direction or the methodology in some way. Like if you've done it already, I have no chance of influencing it at all. But that's the constraint. Yes, you can also work in pairs if you'd like. That's up to you. In the past, most of them have been individual. Occasionally, we've had a couple of students pair up and do projects together. You do whatever you'd like. Questions on this?
I'd like to do project-based work in my research, use that for like my thesis.
Good.
I know nothing about this. Do I have to like worry about IRB or like some regulations of human subject study? Timeline.
Yeah. So if you need to collect data that requires IRB clearance, if you do human subjects research that requires IRB clearance, you will need to do that on your own. It's actually not very hard to do this. It takes a week or two to get it approved. It's no problem if you do this, but you should start early if that's where you're going. Because if you end up with nothing to show at the end, that's probably not ideal for the class. So if you end up needing human subjects data, you should start thinking about how to obtain it and to clear IRB as soon as possible. I can help navigate that if you need help, but otherwise, yes.
Wow, how's this? IRB research.
Usually, if you run interviews with research subjects to collect data, or maybe a survey with practitioners or something like this, that usually requires IRB. If you run a controlled study with human participants in like a lab setting, maybe you give them tasks and you measure them and observe their performance or something, that usually requires IRB. If you analyze logs, the public data, that usually does not require IRB. So if you're mining data from GitHub, for example, that probably does not require IRB. A good question. Any more on this?
But if you're using like traces of people's interaction on web pages, that does require an
Public data usually does not. Yeah. Okay, so this is going to be the main thing that I will ask you to do. I will occasionally ask you to do small homework assignments. For example, maybe I ask you to write a small literature review on a particular topic from 1 week to the next, or maybe over 2 weeks, or maybe ask you to actually conduct a couple of interviews with maybe colleagues on campus. You wouldn't require IRB for this. You could do this informally and to write up your experience there. Or maybe I give you, a data analysis, small homework. Last time we used, what I learned is actually public internal CMU data. So as long as you have a CMU, account, you can access this anywhere. On the student evaluations of all of the courses and all of the instructors across campus, there's internal public data for all courses and all instructors, which I did not initially know about. I learned about this last time. And this was an amazing, data set that we played with last time the class was offered. We could study, various kinds of biases that may creep up in these student evaluations and whatnot. It was fun. So, we may do that again. We may do something else this time. I haven't decided yet, but you can expect some of these things throughout. They're meant to be sort of, small weekly homework assignments that you could do quickly. The project is what makes the difference. That's half your grade. The other half, roughly, is, the homework assignments, the few that we'll be having, and just participation, showing up and being engaged in class. So that's sort of the structure. There's a tentative schedule. You can see this also best on the website, and you can also look at the one from last time. So, we'll be going through probably roughly this progression from more qualitative to more quantitative methods, which follows this sort of state of knowledge progression that I talked about earlier. And the more we get towards the data analysis stuff in the second half, the more of these hands-on things, in-class activities we will have, because it's, it's easier to do those than to do qualitative analysis kind of hands-on in class. So we'll have more of those in-class activities. There are, I think, recordings and slides from spring 2024. You can look at all of those to get a sense of what this is like. Things will change, but it's, it's going to be similar flavor as last time. Okay. Very quickly to end, this class is not a software engineering class. So if, however you're feeling about this, if you like software engineering or hate it, this is not a software engineering class. This is much more a general science class. It's secretly a class about communication. We will be practicing crafting arguments about your claims in research papers and giving talks and whatnot. It is also secretly about peer review, because we will be critiquing a lot of these research papers and thinking very deeply about what makes a good and a bad paper. And really coming back to the point I made at the very beginning, calling bullshit. This class is about hopefully developing your a healthy dose of skepticism in you as researchers, as scientists, so that you can hopefully be more skeptical of claims you will see in papers that others are making next time you read them. That's it. Let me end here. You can tell me a bit about what brings you. Don't want to keep you now. You can tell me a bit about what brings you to this class when we meet on Thursday. We'll start from there. So no homework just yet. Come back on Thursday, and we will continue. Thank you.